Snowflake. If you heard so much about Snowflake and you wanted to know how it works, then I will summarize it for you in a few minutes so that you would understand what Snowflake is. So basically, when we have data and we want to do some SQL select statements on this data, usually we use databases, but we know that databases are limited and we need to manage all the partitioning or use complex and pricey databases to do this for us. So Snowflake said this: we store all the data in S3, which is very cheap to store. If you do not run any SQL currently right now, if you right now don't run any SQL on the data, then you would not be charged anything, but actually only the S3 data storage. So this would be very cheap. And then once you try to run any SQL statements, and Snowflake take the stance that you create data with the DDL, you create tables, and you can then run standard Spark SQL on these tables. Once you run some SQL and computations to get the data, it would start some EC2 instances. You will pay for these EC2 instances, and then you would get back the results. But if you do not run any computations, then all your data is stored in S3. And now, of course, you ask, but how do I load the data into S3? So Snowflake takes again the stance that you use standard DDL. You use create DB DDL, you use create scheme DDL, you use create table DDL, and you also do the loading of the data. And then the data would get stored in S3. But this would not be enough for you to do the select SQL statements and get the data, because in which folder, which object do you need to get, and if there is a big file with a lot of records, then how would the SQL know where to get them? This is where Snowflake come into place. It says, okay, so I store the raw data in S3, I run EC2 instances in order to run the computation and to execute your SQLs, but I will also have a layer on top of the S3 data storage that would allow me to quickly get the data for you. I as Snowflake, do the partitioning and also micro-partitioning and also transfer the data into a columnized way. I will do the compression of the columns. I, as Snowflake, will add automatically headers for you that would store the offset indexes of the data in S3 so that you can just come, write some SQL. I will start the EC2 instances for you. You do not need to manage them. I will then use the metadata that I stored over this data in S3 to get the data, the columnar data, to get the values, to uncompress them and present them to you. Okay, so Snowflake is doing all this for you. It's telling you, okay, the storage will be simpler in S3. I will do all the metadata handling. You just deal with your SQL. I will take all the rest. If until now you used some database and you needed to do the partitioning, or you used some heavyweight services which did the partitioning for you, but they were costly, now you can eat the cake and leave it complete. Because if you don't run an SQL, this is simple in S3. If you run SQL, I will start EC2 instances and you will pay for them, and you would know exactly how much you need to pay. The reason that I think I like this architecture is because it can provide you with a very profound way to store your data. You store it in S3. What could be more natural for you? But S3 is limited because it's an object storage. It's not a database. So Snowflake would add all the additional components and the metadata. But then you say, I have all the S3 latency. It's not that fast. And also I cannot update files in S3. It's only append only. It's only addition only. So Snowflake will take care of this. So basically Snowflake has three main layers in its architecture: the storage, S3, the computation, EC2, and then the top layer, which is the metadata, which it appends, and the compression of the columns to transform the data to be columnized, and all this to enable you to create standard SQLs. It would turn on the computation instances once you run actual computations, and it would turn off automatically the computations once you don't need any computations. So basically, it's a database for you, a big database for you, which allows you to use standard cloud services on cloud only for you to run SQL. It supports the ACID transformations, and it could also integrate with the other services such as Kafka and other enterprise services to get the data from. It also has a CLI that you can use and everything that you expect. But I think now we all get a strong feeling of what Snowflake is. Store raw data in objects. I will do all the metadata and all the handling. I will keep the pricing cheap, because if you don't run any computation, you would only be charged on the S3 objects. I will do you don't need to mess with all the partitioning and all the storing of the data. You don't need to mess with indexing, no more create index. We are talking here about big data. You don't need to invest in scaling of the application. I will store all the data simply in S3. I will start EC2 to do the computations, and I will decorate the data so that when you run SQL, I can fetch these objects for you. So I think this was very interesting. Snowflake is very interesting for big data storage and analytics, and for keeping things simple, I think, and for keeping the computations separate, keeping a lower cost. Of course, it's not an online, real-time database for your transaction, but more of an analytical one with SQL, which we all love. So thank you for listening. See you next time.